Okay, so a minute ago we looked at the recurrence a sub n equals 2, a sub n minus 1, where a sub 0 was equal to 1. And what we figured out was the generating function for this, which had the form the sum from n equals 0 to infinity, a sub n x to the n, was equal to 1 over 1 minus 2x. So now, how did that help us? What new information did we gain from discovering this relationship? Well, actually, a lot. But that depends on knowing a few things that we may know already, and if we don't, we need to know them. So the first is a basic fact from Calculus 2, which is that if x is a real number and the absolute value of x is less than 1, then 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus dot dot dot, which is the same thing as the sum from n equals 0 to infinity x to the n. If you were only going to know one if you're only going to know one infinite series, this would be the one to know. And so when we look at 1 minus 2x, well, we're dealing in a situation here where we don't really care about the convergence. We're just looking at these right now as purely symbolic objects. So we can take this and we can play pattern matching. One over 1 minus 2x is equal to the sum from n equals 0 to infinity of 2x to the n, which is the same thing as the sum from n equals 0 to infinity 2 to the n x to the n. Now remember, we started out this whole discussion by saying that's the same thing as the sum from n equals 0 to infinity a sub n x to the n. So, if you believe this equality, then you also have this string of equalities. In other words, the a sub n lines up with the 2 to the n, and we have solved our recurrence. The closed form solution of this is a sub n equals 2 to the n. Using the method of generating functions, we're able to see that answer.